Hi, this is Aditya. I just wanted to walk you through the vector shift technical assessment that I just recently completed. So the core challenge was building a scalable pipeline builder UI, thinking ahead about how the product would grow. So I approached this in four parts or four things, basically, like building a reusable node abstraction, then designing a professional UI for that, then implementing dynamic text logic as well. Then after that, integrating the backend with graph algorithms, like the Khan algorithm. Now, first, let me start with the architectural things first. So first, the node abstraction type. So the original code base had about four node types, each with around 40 lines of boilerplate codings, in which it was having imports, the state management coding, the JSX as well, and of course the stylings as well. So that doesn't scale well. So what I built a base node which is having a single and configuration driven component. So as we can see it here in the base node.js, it has configuration objects with title, fields, handles, etc. So the component renders everything in a very generic way. So after that, no copy paste is needed. Now we can add more custom new nodes. If I give an example, prompt node.js type, it has like 15 lines of coding, which defines the titles, fields, like template, and the role as well, and handles for input and output connections. So in this way, I created like five custom nodes, like the prompt node, the filter node.js, the transform node.js in this way, all with only zero boilerplates. So this is what we can, this is how we can move from like four nodes towards numerous number of custom nodes. Now next, the design. The vector shift is a consumer-ready product. Non-technical users must have to feel confident while using that. Hence, I choose a very lightweighted professional theme inspired by its own actual branding itself. Now, as we can see in my local post, as we can see in the noticing this semantic color grouping, it has indigo for data flow nodes such as input, NLM, and output nodes. It has green for content such as input text, the prompt node as well. Then we have Amber for the logic nodes, such as filter, transform, or even the API callings as well. Then after that, we can say that it has a very real tabular icons. It has intertypography and the consistent spacing as well. So each node has a very clean header with icon and category labels. It has proper field stylings as well and the position handles as well. So the whole canvas responds very smoothly in this way. So when we talk about our dynamic variable handling, we can show the most sophisticated node, that is the text node. So first of all, when I drag this text node, as we can see, the content, it has two curly braces inside it, and it has the text which is having input. So firstly, it has the most useful feature, that is the auto resizing feature. When I type more and more, as we can see, it is auto resizing itself. Then moreover for that, when I type, this is with two curly braces, user input. As we can see, a newly dynamically created handle is just appeared at here with this. When I continue typing, such as, and also, it has two new handles just created. So this regex code inside the text node file, as we can see, it ensures that we only match the valid JS identifiers, starting with letters, underscores, or even the dollar signs. So the under two curly braces, which is having 1, 2, 3, won't create a handle, but underscores my var, that is my variable, that can do that. Hence, the extract variable function deduplicates itself. So if the same variable appears twice, we only create one handle at the same time. Now, moving on to the next lines of major code part, this dynamic target handling. As we can see, for each extracted variable, we render a handle on the left. They're evenly spaced top to bottom, as we have seen inside our UI on the local host. Hence, all are done dynamically. So this is what makes this text node so much powerful with that. Now back to the application, our local host. Uh, Here I have these two nodes, the input node and the output node. When I try to connect their edges at here from input towards the output, as we can see, they're connected now. So now what happens is that when I check with the run pipeline, it gives me this alert. So at here, the front end sends the nodes and edges onto the backend. The backend calculate basically the three things: the nodes, the edges, and the most important thing, that is it a valid tag or not. So first of all, a tag is basically a directed acyclic graph with no cycles as a condition. So right now this pipeline is obviously acyclic. So it is saying us a yes, that it is a valid tag. The nodes obviously are two, the input node and the output node, and the connected edge between both of them is one. So if I connected the input back to the output, it could have run forever, because then it would have made up a cyclic graph. Hence, the backend would detect that using a Khan's algorithm, the industry standard topological sort, and it would return the valid tag with a no answer instead of a yes. If I connect the output back to the input, but at here we can see it's a yes because it's a acyclic graph. As we can see in this main.py file of the backend folder, we can see the Khan's algorithm logic at here. It repeatedly removes the in degree zero, as if all this type of nodes get removed, hence no cycle will exist, which proves the point of the tag validation itself, as we can see in this code logic as well. The in degree node that is zero, we can see in this Q logic as well, we can see in this edges logic as well. Now to summarize this, I built a scalable architecture with configuration-driven nodes, powerful and professional UI that customers would trust, a sophisticated reactive logic with regex-based variable detection as well, and hence uh, a proper production-grade backend integration system with proper graph algorithms as well, as we can see. Now, I would like to say thanks for reviewing this. I'm excited to discuss more about it in our actual meeting. Thank you so much.